Hi, this is the second video in Unit 3, Atomic Structure. Well, legend has it that a Greek philosopher around 400 BC named Democritus first suggested the existence of atoms. He believed that all matter was made of indivisible and indestructible particles that he called atoms. It wasn't until 2,000 years later that John Dalton, an English school teacher, continued on with his theory of atoms. He was studying the ratio in which elements combined in a chemical reaction, and he came up with what was known as Dalton's atomic theory. His theory says that all matter is made of atoms. That's true. He said that the atoms are indivisible. Well, we know that is not true because of the subatomic particles. Atoms they are made of smaller particles, the protons, the neutrons, and the electrons. He said that all atoms of the same element are the same. Well, that's true if we would say have the same number of protons. But because of isotopes, all atoms of the same element are not the same. Remember, an isotope means they do have the same number of protons, but they have a different number of neutrons. So this postulate of his atomic theory wasn't completely true. He also said that atoms of one element are different from atoms of other elements, and we know that to be true. And he said that atoms of an element are not changed into atoms of a different element when they go through a chemical reaction. In other words, atoms are not created and they're not destroyed in a chemical reaction. We know that to be true. Nuclear reactions are a different story, but that's for another day. And then he said that atoms could combine in whole number ratios to form compounds, and we know that to be true today. So even though all of his postulates weren't completely true, he made great strides in the development of the atom. Well, about the same time, or in the 1900s, late 1800s, a lot of scientists were experimenting with the cathode ray tube, or it's called a CRT. And what a cathode ray tube is, it's a glass tube where most of the air has been evacuated out of the tube. It has a negatively charged plate that they call a cathode, and a positively charged plate that they call the anode. Well, with this cathode ray tube, they went ahead and they connected the cathode and the anode to a high voltage source, which is shown here. And what happened is the cathode was emitting some invisible rays. And these rays were attracted to the anode, which had a positive charge. Now, here's a very important idea that we have to think about in chemistry. Opposites attract. So, these particles in this ray were attracted to a positive plate. And we know that opposite charges attract. So in other words, negative particles are attracted, or they stick to, positive particles. The other situation is that like charges repel one another. So a positive charge will repel another positive charge, or a negative charge will repel another negative charge. But here what we have is we have these cathode rays being attracted to a positive plate. Well, this led to the discovery of an electron. J.J. Thomson had a really sophisticated cathode ray tube. What he did is he put a tiny hole in the anode to allow just a small stream of these cathode rays to come through. So these cathode rays would then come down, and he put some material at the end of his cathode ray tubes that would fluoresce when the cathode rays would hit it. So now he can see exactly where the cathode rays are hitting. Then he went on and he added these two plates that had electrical charges. So one was positive and one was negative. So in this experiment, this plate would have been the positive plate. right here. This one's positive, and this one would have been negative. And look what happened. The cathode ray, so the dotted line coming out here through this tiny hole in the anode, was then attracted to that positive plate. You could also think of it as being repelled by that negative plate. And he concluded that cathode rays had a negative charge. Well, he also did some further experiments, and he was determining that the mass of these cathode rays were much smaller than a hydrogen atom. And so he concluded that atoms contained small particles that were negatively charged. He didn't use the word electrons, he used the word corpuscles. But we know now that they're electrons. So this was a big deal. It was the first time that someone had discovered a subatomic particle. So Thomson discovered the electron, and he discovered that it had a negative charge, and that atoms were made up of these electrons because they were so much smaller than the mass of the smallest atom known, the hydrogen atom. Well, he won the Nobel Prize in Physics for his work in 1906. Well, now we have to talk about radioactivity. And Becquerel was a scientist who discovered that uranium was just emitting some sort of rays that were exposing his photographic film. And these rays were just spontaneously being emitted. Well, Marie Curie named these rays radioactivity, which she said was the spontaneous emission of particles. She called elements that emit these rays as radioactive. Well, there are several types of radioactive waves that we need to talk about. The first are alpha rays, and it's really important that you know that alpha rays have a positive charge. Now, they are helium nuclei, which means they have 2 protons and 2 neutrons. They don't have any electrons, so they have a positive 2 charge. Now, compared to a proton, a neutron, or electron, alpha rays are huge. So they're very slow moving, or we could say they have low energy. They can't even penetrate your skin. You can block them with just a small or a couple of pieces of paper. Let's talk about other radioactive particles. There are beta rays. Those have a negative charge, and they're electrons. So they're a lot smaller than alpha rays, and they have a lot more energy. In order to block a beta ray, you need some thick plastic. And then there are gamma rays. They have no charge whatsoever, and they're the highest energy. Well, the reason we had to talk about the radioactivity is because they used an alpha particle when they discovered the proton. So at this time, what was known is that atoms were neutral and electrons had a negative charge. And from our timeline, we saw that J.J. Thomson proposed the plum pudding model of the atom, where we just had negative electrons just kind of floating in the sea of positive material, and that's what he called the atom. But Ernest Rutherford was studying alpha particles, and what he was doing is he was bombarding different kinds of metal with these alpha particles. And he did a famous experiment called the gold foil experiment. When he had these alpha particles being emitted and hitting a piece of gold foil, he noticed that most of the alpha particles went straight through the foil, as if no gold atoms were even there. But every once in a while, the alpha particle would hit something and it would bounce back. What was it hitting? Well, here is a picture of his experiment. So you have some alpha emitter in here, and this red line is the alpha particle, and most of the alpha particles go straight through the gold. So it's like there's nothing there in the atom. But every once in a while, an alpha particle would come right back from where it originated. Now they could see where the alpha particles were hitting because they had some zinc sulfide that would show flashes of light when the alpha particles would hit there. So what was that alpha particle hitting? And it only hit this a few times. Well, the conclusion was that, first of all, most of the atom is just empty space. And that alpha particle was hitting something that was very small and positively charged. Remember that like charges repel. The alpha particles are positive. The nucleus in those gold atoms were positive. So when the alpha particle would hit that tiny target, it would be repelled back. And so what that alpha particle was hitting was the nucleus. So Rutherford discovered not only the protons, but he discovered that the positive charge in an atom is concentrated in a small space that he called the nucleus. Well, we don't have all the subatomic particles accounted for yet. We still need the neutron. It was the last particle to be discovered, and there is a problem. The mass of the atom was not adding up. James Chadwick was bombarding beryllium with alpha particles, and what he found is that some high energy radiation, kind of similar to gamma radiation, was being emitted. Now remember, gamma radiation didn't have any charge. He was observing, and he discovered the neutral radiation was a neutral particle known as the neutron. So there we have it. The atomic structure and the history behind the discovery of the electron, the proton, and the neutron. Have a good night.